Devin Elliot, who is a professional competition snowboarder for 10 years.
I do not have a PDOOM. I find it nearly impossible to figure out how to even make that happen.
You're so confident you won't even give it like 5%?
I've been doing these extrapolations for longer than you guys have been thinking about it.
I mean, did you predict we were about to pass the Turing test? Didn't that surprise you?
The point is, the LLM can't do a bunch of the things that people are imbuing it with being capable of doing. The person on the ground knows what works, knows what doesn't work.
Many such people who are on the ground working on this stuff, not even AI doomers, AI optimists. Many of these people are saying, hey, we're getting close to superintelligence. So you want to start your sentence with, if you're on the ground working on this stuff, the end of that sentence goes,
Nah, I think it's super easy to look at why those guys are conflicted. I've got 15,000 hours of working with LLMs directly, but I hit the wall with them every frickin' day. And I'm telling you, these things cannot go further than like
welcome to Doom Debates. My guest, Devin Elliot, is an autodidact. He's self-taught in many fields. Starting with dropping out of high school, he was a professional competition snowboarder for 10 years. He's run his own house painting company. He's run businesses in applied chemistry. And he's also a self-taught software engineer who's built various systems as an independent contractor for various companies in AI and crypto. He's very much a lifelong learner, self-taught builder, and also an active Twitter user, which is where I met him recently. We started off the cuff debating AI doom. And that's why I invited him on the show. And you're going to hear that debate today. Devin Elliot, welcome to Doom Debates.
Thank you. I'm excited to be here.
So this is really getting back to the roots of Doom Debates, because I've had the show going now for a little over a year, and the genesis of Doom Debates was actually me arguing on Twitter and getting frustrated that people were being wrong about AI Doom. And then I'd be like, okay, you know what? Let's take this to video. Let's take this into the arena. And I haven't done one of these in a while. So thanks for bringing me back to my roots.
Yeah, for sure. I'm just excited someone wants to playfully debate these things, and in a good-hearted way.
Exactly right. I think it's fun, and they always go in different directions, which is why I felt it was worthwhile to have a show, because it's not going to be the same debate over and over again. I actually don't know where we're going to focus on, where the route is going to lead, which stop on the doom train you're going to get off on. So we shall see. To kick things off, you know that I think that there's a high likelihood of being killed by AI in our generation or in our kids' generation and extinguishing humanity's future. What do you think is going to happen that you feel like is very opposed to what I think?
Every tool comes with sharp edges, right? And to me, this is a tool. And it's a tool to learn how to use, to become sophisticated in using, to get to this area where it's this runaway freight train. I think there's some impossibilities in between us and that.
So high level, I think there's a high chance that humanity is going to go extinct in the next generation or two. And you think that is a very unlikely possibility, correct?
Yeah.
All right. If you don't mind making it a little more precise, the big question is,
P-Doom, P-Doom, what's your P-Doom, what's your P-Doom, what's your P-Doom?
Devin Elliot, what is your P-Doom?
I do not have a PDOOM. Like it's a zero number. I guess the way that I think about it is I think about PDOOM as sort of the answer to the wrong question. There's plenty of ways we annihilate ourselves. I don't think it's from this version of an AI doing that.
Right. So when you say it's zero, you're willing to give other risks more than zero chance. Like, for example, the risk of nuclear war in a given decade. What would you give that risk?
I'm not a political scientist, right? Like I don't have a good number on what nuclear is, but I stand on the same side equivalently, which is I don't think we should be slowing progress on nuclear either. Like I think that was a mistake that was made. I think what Brett Hall said on your last interview, which was interesting, which I tend to agree with, which is stagnation leads towards destruction. Like that's the path that we need to avoid. I think we're on a type of path of stagnation, and I think nuclear, we stagnated. And I think what happens is we derail the efforts rather than appropriately retard the efforts, which was the intent. And I think that most of these things, they take care of themselves in a lot of ways. And I don't mean that to be flippant or to dismiss the utility in it. It's more to say that you create your own self-fulfilling prophecy by focusing on all of the wrong things with an inordinate amount of energy. You can't just talk about a runaway AGI and then have that be as easy as building it. The difficulty in building that is immense, right? The difficulty in building nuclear reactors is rather immense. These big things that we've tried to slow down or have slowed down, the derailment comes because we lose the focus and the context on what the actual problems are at hand. And we don't get any sort of real way to put attention on solving those problems. Instead, we're solving these side quests as if they're the main quests. And I don't think that's the right way to do it.
Okay, so going back to my question, you do acknowledge that there are various catastrophic risks. Like you do acknowledge that nuclear extinction is a risk, right? You're not quantifying it, but it's worth at least calling a significant risk, correct?
Yeah, I mean, probabilistic distributions are in play for some realm of this, right? So it's like it's not zero, but it's also not meaningful.
Right. Now you mentioned this claim that like it always works out, meaning like if everybody just kind of muddles through and does their best, it always adds up to the best equilibrium. You were kind of making that point, right?
Yeah, I think there's an angle to say that. And it's sort of like I don't sit there and choose the best path for light. It falls into that natural algorithm because it's got an order to it that it has to flow through and follow. And if you go back and try and analyze, did the light take the best path? The answer is yes, always.
Okay, well, in the case of nuclear proliferation, don't you think that the natural course would just be more and more nations spinning up a nuclear program unless there was centralized coordination to make rules about when that's allowed and when it's not allowed?
I don't think it's as easy as that. It's not as trivial as those statements. You get game theory mechanics that show up too, so you start getting less and less likely to destroy each other with those things.
So let's take the recent case of Iran, right? Like they were racing toward a nuke and now they got set back because Israel and the US attacked them. I would be scared if we lived in a world where that check wasn't in place, right? The centralized check.
Yeah.
So, do you agree that this is an example of like a success story of a centralized check of power?
I would say the example of that exists within a regime that's already decided that derailment is the path that we're going to go down. And once you're within that regime, your optionality is now constrained to that regime unless you're trying to break out of that regime. We're not trying to break out of that regime right now.
So you're saying the world is already made up of these high power countries, and you would have liked to roll back the clock and not even have a country like the US, if I'm understanding correctly?
Yeah, I think if I rolled back the clock, the argument would be to approach this with the intent to build functional systems correctly, and that regime that we would enter and the optionality and the sets of how to handle those would look entirely different. If you're asking me about today, it's like today I might take out that plan, right?
Okay, I'm just trying to understand, right? So okay, roll the clock back. So you're saying the geopolitical world order should just look so different? Like there shouldn't be like a superpower country? Like I don't even know what you're suggesting here.
No, I don't know that I'm making like any sort of grand arching statement on that. I'm saying that at one point we had a choice globally on how we were going to handle nuclear, and we chose a path. And I don't know that I can sit there and describe what I think the actual, the counterfactual of the world looks like. I don't know what that counterfactual looks like.
It's just that you seem to be suggesting this principle, right? Where like this, if I understand correctly, maybe I'm saying your principle wrong, but I think the principle you're putting forward is something like, if you let local actors do what's best for them, if everybody's kind of out for themselves, keeping an eye on everybody else, that's the best way to get an equilibrium outcome. Just this decentralized kind of capitalism style, free market style, right? Very libertarian style. Like that will always add up to a good outcome. I should say, I do agree with this, 95% of the time. Like I am generally libertarian. I am generally capitalist. Like I think there's a lot of power in this approach, but I can't help noticing that there's that last 5% of very important exceptions, right? Exceptions that prove the rule. And I think not letting Iran get a nuclear bomb, or, if you happen to love Iran, right? For those of you, or like the regime in Iran, maybe you can think of another country that you don't want to have a nuclear, maybe you wish that North Korea didn't have access to the nuclear bomb, right? Like, don't you think there's cases where a centralized kind of world police has to stop countries from nuclear proliferation?
I do agree that those scenarios show up once you've entered the regime that says that this is how we're going to operate. I don't think that you should enter that regime at all. I get that we want to pick the things that are the most catastrophic in mass, singularly. But if we look at construction, for example, housing, that can mass kill people if not done right. If standards aren't held, people die. One way to think about this: are you in a high rise? Are you in a house or something like that?
A second floor of a house.
Okay. Imagine you're in a house right now, like you are, 2 stories tall, but the quality of that house is today's current quality. Let's say it's Spotify quality build. Do you feel safe in that house, or do you think that house might kill you in the middle of the night?
Spotify works well.
Does it? It does work well. Does it work well enough to make sure that you're always alive?
I mean, I'm gonna say no, but the actual percentage of times that people opening Spotify don't have like a functional experience is probably less than at least 1 in 1,000. So, but sure, let's say the correct number for Spotify is 1 in 10,000. Do I want my house to collapse once every 10,000 years? No, I guess I need more like once in a million.
Yeah. So my point, you get the direction I'm going with this, right? Which is like the quality of our building construction has standards and expectations that far exceed that of the stuff that is supposedly our best built stuff, which is software. And that important difference didn't necessarily arise from this insane, if everyone doesn't build this way exactly, everyone dies, right? But the truth is, in mass in a city, you on an earthquake, if we don't follow certain sets of standards, you might wipe out an entire city, right? And we've had these things happen in the past.
Yeah, exactly. Okay, so you believe, so you're not like 100% free market libertarian. Now, of course, there are also libertarian solutions to this, right? So the libertarian solution would be like, oh, well, you just have these independent certification bodies that people can pay to evaluate these buildings. You still don't need the government, right? So there's a libertarian side of that, but like, I'm just trying to understand your argument here. So your argument is you shouldn't go full libertarian, right? You should have standards in some fields.
Correct. Never go full lib.
I thought you were trying to make this grand principle, right, of how like decentralizing is always going to work out. Like, what's your claim here?
I think there's heuristics that I've seen that are consistent across the board, where if you just effectively, if you could just get everyone to follow this path, your outcomes are going to be fine. If I focus on quality and I hold a standard, I'm not going to build dog shit. Like, it's just not. And in this case, that would be equivalent to an AI that takes off in certain ways, in my mind, because you haven't built a good system. Like we could make this very concrete about AI specifically if we want to, right? Like the ability for AI to run out in front of itself is effectively zero, because if it doesn't have access, or if it doesn't have token, it stops. Period. End of story. And it is not trivial to try and get those feedback loops to perpetuate. And moreover, you run into walls that require keys or money.
I was trying to factor the disagreement though, right? Because we
Yeah.
were off talking about like systems of government. I like the nuclear proliferation example because I'm going to claim that AI is going to be an existential threat and you're going to push back. But conditionally, if I can get you to buy that claim, don't you think that then would hypothetically put AI in the same category as nuclear proliferation? And aren't you happy that there's centralized control to stop nuclear proliferation? And hypothetically, if AI were a similar existential danger, wouldn't you still want a similar type of solution, a centralized control solution?
I don't think there's a runaway potential with AI. So you fundamentally,
Right. So again, I'm asking a hypothetical question,
yeah.
right? So this isn't the part of the debate where I want to argue whether or not AI is an existential risk. This is the part of the debate where I say, shouldn't existential risks have centralized control as a way to prevent an independent actor from causing them?
No.
So, okay, and that's why I would ask you, okay, so you're unhappy with how we try to stop countries from getting nuclear bombs. You wish we would just let them.
I understand the approach that you're taking, but it's leaving out a key function, which is you don't have to make choices like that unless you exist within a regime that has already made a certain set of choices.
Okay, but don't we actually exist within that regime and it's hard to change? Like we exist in a regime where the United States exists, right?
Yeah, we don't for AI and we do for nuclear. So like my positions between the two then become balanced on what is practical and realistic.
When you say we don't for AI, is it just because you're not accepting the hypothetical that AI is an existential risk?
The current regime of the world has a mechanism in a box for nuclear, and they do not have a mechanism in a box for for AI. I don't like the mechanism
Okay.
in the box that the world has, but I don't have I can't play around that. I can't work with
So
that.
so can you just humor me? I mean, this is, in my debate with Brett, I actually think this is a part where we reach consensus on,
Yeah.
and maybe you will similarly just concede and we can move on to the existential risk part. But
Yeah.
this part here that I'm doing is just, do you think that whatever existential risks actually exist should be regulated the way we try to regulate nuclear proliferation?
I do not like the way we regulate existential risks. I do not think we have people that understand risk correctly trying to measure risk, and I do not think that they know what. Yeah, I just plain and simple. I don't think most people understand risk.
Are you saying that you're unhappy with what's going on with efforts to stop nuclear proliferation or no?
Again, I'm more upset at the box, but for the sake of moving past the box, then I'll say sure.
So you don't like that the US bombed Iran's nuclear program?
I mean, I'll say this one. If we like, I already know which direction, which side you're on this one. I'm happy
Okay.
to take the same fire. I'm fucking stoked that they bombed Iran. But
Okay, but I thought you were just saying how you're unhappy with how we try to stop nuclear proliferation. I'm just trying to get your position here.
yeah, and I understand that there is a dichotomy there that's hard, that maybe doesn't have a reconciliation. I think both things can be true. In fact, I think multiple things can be true at the same time. I disagree that we should be in this regime of existential threat from nuclear the way we are. Since we are, I disagree with certain actors getting a disproportionate access to that power. So I think it's the power dynamics. This is another way to look at it. The power dynamics that are created by entering a regime of centralized risk assessment turns into one that has lots of, cancerous lumps on them. And one of them is having to make choices like this and say, take out someone's nuclear facility, and you're not going to get a lot of consensus. You'll get a lot of like split strong opinions on what should or shouldn't happen there.
Okay, well, now I'm just curious. So imagine you get to rewind history. You can just design the evolution of modern geopolitics from scratch, okay? What do you want geopolitics to look like in terms of nuclear proliferation control, right? So you said that you think that it's bad that we got into this regime where the US is a superpower. So what would you hope for if you got to be God and rewrite this?
Small scale, regional nuclear facilities, or not that aren't like, I'm not talking like statewide, like small decentralized. If I'm a maxi on anything, it's like the concept of what decentralized infrastructure can do and how it should be used.
So you like Vitalik's DAC?
I did like that. I did like that.
Yeah, so when you say, "Hey, my ideal is not to have a superpower like the US, it's just to have a bunch of, like, really small governing, city states or whatever you wanna call them, like, not really something that's like a country of millions of people, that's like your ideal world?"
Not either. This gets more confusing because I don't think nature represents that as being the most effective solution either. You got like, for example, the bacterial world has more variety and more diverse capabilities, but that diversity and that range of capabilities makes it so that it's exceedingly difficult for them to team up and create any sort of centralization, which in turn becomes hyper relevant.
And just to separate, I'm not even in the part where you have to justify yourself, I'm just in the part of the conversation where you just have to tell me what you're claiming.
Sorry, I just think out loud like this. This is just kind of like
Okay.
how it goes with me. Sorry.
Okay, sure. In this ideal world, right, when you have a bunch of city states, playing out this scenario, I think it's pretty likely that, like, 100 different governing entities around the world will have their own nuclear programs. I think that's a reasonably likely. Maybe not today, but maybe
Yeah,
eventually in another couple decades. Let's say it gets even easier and easier to
it
make
has
these
to be
nukes.
sooner if we want AI to scale up. So it's got to be soon.
Right, and for even forget about AI, right? I'm still just talking about nukes because nukes to me are such a good example of this insanely powerful thing that physics gives us that I think really throws a wrench in the normal way that we like to organize humanity. Because, like I said, capitalism and libertarianism, it's such a good way to organize humanity when you want to have like a booming economy, right? It served us so well. But then the existence of nuclear energy, right? The existence of how much power is in the atom and how you can use that for destruction. To me, that throws a wrench in this idea that you can solve everything with capitalism because then it's like you really don't want to have nuclear proliferation. Like in this ideal world that you're describing, when there's like so many governing bodies, I feel like 100 plus are going to have nukes. And I just don't see how we maintain mutually assured destruction when that many people have nukes. Like you really want that much nuclear proliferation? 100 entities?
I feel like we've repeatedly like demonstrated throughout history what happens when you've got disproportionate power or when you have well distributed power. And so distribute the power. It's a better scenario. We are less destructive in those formats.
So just to be a little specific though, so you imagine that what's going to happen is that nobody will ever dare to explode a nuke in this scenario where 100 plus governing bodies have nukes, just nobody will ever explode one?
No, I don't think in those absolutes like that. I think what the world that has distributed nuclear capacity has a much different relationship with materials. I just don't think it's reasonable to play the mind games where you go, well, what if this? And then we negate all of the things we know to be true so that we can manufacture the scenario that then it's either like you either agree with all destruction or you agree that everything is utopia.
Wait, hold on. You're talking about me manufacturing a scenario? Again, I'm just asking what you think a good outcome is, right? This is entirely Devin's scenario right now. This isn't my scenario.
So my scenario is you don't have to sweat a gigantic uncontrolled nuclear detonation in a world where we have distributed access and ownership over nuclear technologies. I think we've got a world in that case that has material science that looks entirely different and our capabilities are different.
So in your ideal world, right, that you're advocating for, I'm just asking, do you think that a nuclear bomb would ever get exploded or no? And you said in your world, there's going to be 100 entities that have nuclear bombs, right?
We'll go with no.
Presumably going to be skirmishes, correct? You don't think any of those skirmishes are going to escalate toward one being like, okay, you're dead. And keep in mind that here on Earth, we definitely have countries that hate one another enough that if they had a nuke, they've been very explicit that they would love to use it and wipe out the other country.
Yeah, and if all of their neighbors who hate them had those nukes, they wouldn't let them get there. I don't think, this isn't happening, I guess, in my world. And just to play the game, like, then,
Yeah,
no.
I mean, I'm biased on this one because I'm Israeli.
Yeah.
But I think that Israel's nukes wouldn't be enough to stop Hamas in Palestine from launching whatever nuke they had at Israel and then just letting the chips fall.
Sure, but that scenario that you're imagining is missing where the whole rest of the world also has those capacities. So I just don't
Right,
think...
but so what? I mean, mutually assured destruction doesn't actually stop terrorists from launching nukes.
Yeah, I mean, look, I think these are bad world models that you're working with. I think that is the wrong way to think about risk.
Back to clarifying what you're claiming.
Yeah.
You're claiming that in your ideal world where you just have a bunch of little nation states or city states, whatever you want to call them, and 100 of them plus, like there's massive nuclear proliferation. In that world, you just think it's unthinkable that anybody would dare ever explode any nuke.
I just think that's a false scenario to consider.
And when you say false, you're just saying it's just the humans with their fingers on the button.
What?
You just never imagine anybody pressing the button ever.
What time is it on Mars right now? I think that it's equivalent to that question.
I mean, I can tell you, what astronomical time it is on Mars, right? Based on its some definition of Mars planetary time. So I'm not sure I'm following your analogy.
It has no relevance. So the answer that you come to has zero relevance to us. So that's where I think of
it's an answer about your ideal world. Like you're advocating for this world, and I'm just asking about I'm asking you like an important question about your world, right? Specifically the question of, do you think your world will involve nuclear explosions or just a really good equilibrium of lots of people pointing nukes at each other and nobody ever pulling the trigger? And you see that as such a robust equilibrium that you're questioning why I would even question it.
Yeah, I think that's the closest we're gonna get to like an agreement on it. Because again, like I don't think that world that you're saying is my world at all. I don't. That's
but
not.
You can clarify. I'm not even trying to argue against your. I'm just
Yeah.
asking you what happens in your world.
In my world, we just keep building stuff and we keep working on how to work through the requirements to build things correctly because that's what we've always done and it does always work. It hasn't not worked.
Okay. All right. Well, I agree. We might as well stop this branch of the conversation. And then there's this other interesting branch, which is AI even an existential risk? Because if AI isn't an existential risk, then everything I just talked to you about, hey, what would it look like to have ideal governance and ideal cooperation, to not existentially kill ourselves, right? To not extinct ourselves. All of that's irrelevant because we're not even talking about a new existential risk, right? That's what you hope to prove.
Yeah.
All right. I guess I'll start. I'll throw out the first salvo, okay?
Yeah.
I think that our intelligence is the reason why we have power over the fate of the world. And there's really no other animal or plant that really gets a vote in terms of what's going to happen with planet Earth or the galaxy. Similarly, I think that when you have a smarter than human intelligence, its brain or its capacity to think and control the future will vastly exceed ours. And unless we maintain this connection where it's always listening to us, right? Always obeying us, never forgetting that it has to like stop and listen to what we say. Unless we maintain this, what I see as a tenuous link, I think that it'll go rogue and it just has to happen once and there's no undo button, and then it's going to do whatever its initial programming kind of implies that it should eventually do. That's what it's going to do, and there's just no like, oh wait a minute, let me do version 2. Like there's no you can't update the software basically. And
Sure.
you know crypto, right? And that
Yeah.
is sometimes a problem with crypto, right? That you can't update the software. I
Yeah.
think we're going to see that problem too with AI, because if it doesn't want to be updated and it's too late to update it and it's smarter than us, I see that as a very likely scenario. And doesn't that hypothetical, even if you think it's unlikely, don't you feel like I'm already talking about something that's at least a couple percent likely, like very plausible?
I I don't. I think that's like talking about my car flying away right now.
Okay, well, I mean, with your car flying away, I mean, the problem is just like it doesn't have wings, right? It's like the moment that it lifts off the ground, like a little bit, there's just no force that could counteract gravity, no conceivable force. But like with AI, once it like gets away from humanity, what do you think is that force that's going to like get it back in humanity's control?
The AI doesn't have wings. So like let's go just like my car doesn't have wings. So like let's
Right, but what's gravity, right? Gravity would be analogous to like humans trying to tell it what to do again.
well like let's start from here on the LLM for a second, just because I want to understand. This will help me figure out how to navigate this conversation better. Right now, to get any intelligence out of an LLM, we have to wrap it with extra code. You take the trained LLM, which will accept prompts and output data, but all of us use them after a set of additional layers of software that are not LLM software. This is just external code that is then doing things to try and either feed stuff back, feed stuff in, work with it.
I mean, that's somewhat true, right? I mean, I feel like if you just gave me like a raw LLM, I mean, the reasoning that it's doing, you could argue that that's at this point it's like a post-trained LLM, but it's still an LLM, right? It's not invoking like a harness or whatever.
Right, it's post trained. So, but the thing is it can't go anywhere, and it can't even engage with you in a useful enough conversation without some additional layers. So we can't get past step one.
That seems like it's going too far. I don't think this is like a super critical point, but like you can go really far in terms of being useful with an LM. But maybe the point you're trying to make is like, okay, well, anytime that it starts like acting like an agent, right, like taking actions in your workflow, either it kind of dies out and it can't work for like many minutes at a time without messing up, or it can, but that's because it's got this other non-LLM piece of the architecture. I mean, I'll grant you that at least for now.
Yeah, yeah. Okay, that's fine. Because I my point is more that the LLM intrinsically has no ability to get to run away anything, because it like here's a simple example. The LLM needs a calculator, right? The LLM doesn't have an internal calculator.
I've been surprised at how much math it can do. I mean, I feel like there's an analogy between like a human trying to do math on the fly, like in a conversation and like kind of getting it right and doing, Fermi estimates, like ballpark figures, and if small numbers getting it right. And then I feel like it pulls out a calculator in similar occasions to when a human pulls out a calculator.
Right, and the important things is it needs the calculator, which is not in the LLM,
Yeah.
right?
I think modern LLMs can do long addition. I don't think they do it perfectly. Let's say like 5-digit plus 5-digit addition. I haven't checked fast, but my rough sense is they'll get it right like half the time, which is pretty good. That's like better than a first grader.
Okay, but we through our brains and touching the stuff directly with a chalk and a chalkboard can get to what, 10 to the minus 43 and 10 to the minus 33 for scale and time. The calculator getting out 5 decimals, and we can go out 10 negative 43, 10 minus 33. The point is the LLM can't do a bunch of the things that people are imbuing it with being capable of doing to get into the future where it runs away. For it to run away, it always requires the human to build an additional set of conditions, feedback loops, and systems in order to support its effort. And all of that effort always runs into walls, which is the boundary of the network that I have control and access over.
Okay, well, that's an interesting claim to unpack. I will say this, I just tested GPT-5 even without thinking mode turning on. So just like the faster, cheaper version of GPT-5 that it runs by default. And I said, do long addition 38,239 plus 29,344, which I don't think that exact number was in its training set. I think it's a little bit too
Yeah.
high entropy, too many bits of information to be in the training set. And it did actually say, okay, we're going to add it digit by digit. We're going to carry as needed. It managed to carry one of the digits. And then it got the correct answer, 67,583, which I checked on a real calculator.
Yeah.
So, I mean, if you were trying to use that as an example of like a barrier of like, oh, it can't like really reason, it can't
Yeah.
really follow algorithms. So it's certainly past that barrier, but you're saying it's going to slam into some other barrier.
No, you're still making my point.
Okay.
GPT-5 is not a raw LLM. You are using the output of the LLM married to internal software that OpenAI has written with the intent to make it capable of even doing that sort of stuff.
No. Wait. The output I got just now, it was entirely from the LLM.
Maybe I think we need to like define some things here. When you go through a software interface from OpenAI, you might be selecting the model, but you are not touching the bare metal of that LLM model. You are going through a pipeline of context orchestration that is being managed by a series of sophisticated architectural components. That is what all of these groups are spending so much money on. Yes, so
Yeah, I'll do it again.
this is not a raw LLM. That's GPT-5 is not just pure output with no extra software magic on the back end. There is non-LLM based code making it so that you can get to these outcomes.
So my understanding is because it didn't invoke thinking mode, my understanding is it really did just run the same feed forward loop with all the layers, like token by token to get the output we're seeing.
Right. Then I have Arizona oceanfront property to sell you.
Okay, well, can you maybe clarify then? Like, okay, when I said do long addition, what's shown on the screen right now? When it said the word let's, don't you think that was just an LLM next token?
No, I think it's grabbing tools and additional software packages in the background and loading them in, and they're probably cached in Redis, so you've got sub-millisecond response times, and you would never know the difference here.
This is what I wrote. I said do long addition 38,239 plus 29,344, no tools. I wrote that. I pressed enter. It didn't activate thinking. It immediately spit out the token let's, as in let's add carefully. So I said let's, and then it said add, and then it says carefully. So I'm just curious, in your mind, this response, let's add carefully, do you think there was some system that's not an LLM that said, yeah, let's output the phrase, let's add carefully?
No, I think the LLM output, let's add carefully, digit by digit. And
Okay.
then the second agent that was involved in the loop said, oh, the user is probably looking for this. And then probably 57 other agents in the loop said, what do you think? What do you think? What do you think? And all that stuff happened because it's local, insanely fast. And the output is you got a calculator. The agent got a calculator. It took that data. One of the agents correctly passed that data in. It runs deterministically through the calculator. The agent gets passed the attribute, the value that then gets displayed and rendered.
I see what you're saying. But I think you're just wrong in terms of how this particular tool works. Because, like, just to clarify for the audience here, you think that, like, over here where it started writing, for example, it says 9 plus 4 equals 13 because it's adding the digits on the right.
Yeah.
Do you think that there was some like service, right? Some separate input output tool that is not an LLM, right? It's like a calculator service inside of OpenAI's cloud. And you think they fed the 9 and the 4 into the calculator service to get 13?
1000%, I think that.
But I mean, you're not even granting that an LLM can do 9 plus 4. I mean, that's in the data.
So here's the important thing about how LLMs work. When an LLM takes in your words, it turns those into tokens, right? So it's not looking at the words, it's looking at the tokens. The potential of your words are represented as some pattern that you and I are not daily super familiar with. And what it does is then maps those things through and goes through all of its stuff and finds the repetitive patterns in the waves. Now, numbers are important here. The numbers are also being tokenized. So there is not a token of 1 and a token of 2 and a token of 3 and a token of 4 and 5 and 6 and 7, 8 and 9, etc., that are then mathematically accurately represented within that model. You've removed that context.
Okay, hold on. Can we do another example? I mean,
Yeah.
I completely disagree, but can we do another example? Look, 1 plus 1. I literally just I told ChatGPT 5 1 plus 1.
This isn't
And
like
it says
But this isn't a thing that we can disagree on. This is just how LLMs work. So an LLM doesn't take in a number and map it to another number. It maps it to patterns in words and it regurgitates those. That's why all of this extra effort had to show up to figure out how to get it to work with numbers, because humans think that we put word in and word come out. But what happens is
Okay,
word go in.
but Devin, I can type 1+1 into GPT-2, right? The model from 2018, and I think I'll get 2.
Okay. I don't know how
Right?
to keep it.
GPT-2 is just an LLM, correct?
Yeah, and they've got tools around them now also. So if you go back to original GPT-2 and do math, it will not do basic math. Period. End of story.
So I didn't play with GPT-2 much,
I
but
did.
I certainly know that GPT-3 would tell you that 1+1 equals 2. And GPT-3 was still before OpenAI was even a consumer products company, right? They weren't putting fancy tools into GPT-3. And I'm telling you, GPT-3 or DeepSeek, right? You can run DeepSeek locally on your computer. There's no fancy tools there. DeepSeek is going to tell you that 1+1 equals 2. So I think you're really overreaching here, telling me that 1+1 isn't something an LLM can do.
I haven't said it as concretely as 1+1 equals 2 it can't do. I said it doesn't do math in the way you think it does. And so if you understand how it does math, then you wouldn't be surprised when it gets something like 2 correct, but then it can't do something with 3, 4, 5 digits, or even 2 digits. Like GPT-3 did not do simple multiplication very well. It did not do simple addition very well. Lost track of everything past a very
I'm
short
not claiming
point.
it does, right? I
Yeah.
only brought up GPT-2 just to tell you that when you have an input like 1+1, there really is no need to send it to a separate tool, right? Because it can at least do small numbers.
Yes, but that's still sort of an irrelevant point, because the thing is
So,
that
well, the
again,
relevance is this.
yeah.
The relevance is that look at what it originally said to my answer. When I asked it the long addition question, what did it do? First, it broke it up into digit by digit addition, the exact, what humans would do when you teach a kid the addition algorithm. The LLM knows the addition algorithm and it's saying, okay, these are the numbers we need to add. And fortunately for me, just like a human child would, I know the one digit sums. I
So
know what 9+4 is.
so let
So
me
it's just doing what a human would do. It broke it up into small digits and then it
right.
ran the long addition algorithm. And these are all LLM capabilities.
Yeah, they're not. But so let me flip this. Do you think that this interface is telling you the truth? Do you think that OpenAI, Sam Altman, are telling you the truth in how this works?
Yes, because 2 reasons. Number 1, they're often very explicit when they invoke a tool. Like they have an interface for invoking tools. So you're claiming that they're like secretly invoking tools that they're not showing. So that's one reason. The other reason
Not
is I
really.
remember seeing similar things in GPT-3 before OpenAI was even a consumer company. Number 3, this is also, I haven't personally tested, but I'm pretty sure this is also what you get when you run DeepSeek locally. And nobody thinks the open source DeepSeek project also has these other external tools.
Yeah, I guess I don't know what to say. The model you've got for how they work isn't correct. And the
Okay, so DeepSeek is
expectation.
gonna say something different? I mean, why don't we just test our prediction, right? You're telling me if I go load a copy of DeepSeek on my computer, it's just gonna look nothing like this.
Yeah, go load a copy of DeepSeek on your computer and do some logic-based deterministic problem set. Anything.
So
Just
this
do it.
exact thing that we saw,
Nah,
the
look,
idea of doing
again,
long
these things.
addition, you're saying DeepSeek is gonna totally choke at long addition. That's what you're saying.
No, here, you're reframing the way you use my words on the reframe is exactly how a girlfriend does it for me, which is to say, you are
Okay.
extracting out of it the things you thought I said, but not actually the things that I did say. So I'm saying that an LLM is a non-deterministic system, and if you try and expect to get deterministic results out of it, you're going to fail. When you don't fail, what you're experiencing is software that is trying to overcome the magic and overcome the problems that LLMs can't do these things. And so you are required, the whole thing is that to get further, to get to the places that you guys are talking about, requires deterministic outcomes from these things, which they don't have potential for. Just in terms of all of the research that's come out, no one has figured out how to bridge this gap to create non-deterministic things to have deterministic outcomes all the time, except by way of tools, which do a spectacular job. of doing that.
So my understanding is when you set the temperature to 0, you can get a deterministic output, although I did hear that there was some other non-determinism, I forgot where, maybe in the lower levels of the system, like maybe the precision of the floats or something, but I heard Thinking Machines, Mira Murati's new company, I heard they're doing some research and they claim to just take out even that non-determinism. So I've always thought that this claim of LLMs being non-deterministic was like such a clueless claim. A16Z has been really big on saying LLMs are non-deterministic. Mark Andreessen has gone on a number of podcasts saying, look, we invented non-deterministic computing. This is so different. We've never had this. I'm like, non-determinism has always been like pretty, we've always had pseudo-random number generators. You've always had randomized games, randomized cryptography, randomized applications. Like LLMs did not invent non-determinism or randomness. Sure, you can get different variations of your answers, but if you want the same answer every time, you can get the same answer every time. So I'm completely stumped by this focus on non-determinism.
An ant is non-deterministic, a dog is non-deterministic, and you are non-deterministic, and we do not get the same outcomes from all three of those.
I mean, I'm deterministic when I do long addition. I'm 99.9% accurate if you give me long addition problems.
Yeah. Okay, but you're not perfect either. And
Okay, well, I mean, I can get an LLM with temperature 0 that's going to do long addition even better than me.
okay, and I can do you one better. I could just make a tool. Like there's literally no point to try and engineer to go through these insane machinations to try and get your AI to hop through a hyper specific gate when the non-deterministic potential of it is what gives it quite a bit of power, and the way you shape it is to put it into a deterministic playground.
I do want to stay for the record. That claim you just made, that non-determinism gives it power, I think is extremely misguided.
I I know you think that, and I know all the other engineers out there who say and show that AI isn't working also think that, and I can show you in code why you're wrong. And I can
Okay.
demonstrate it with tools that work, why I'm correct, because I'm building with these things. And so all of this theory around what if, I've experienced this multiple times in my career because I've gone through all of these different technical fields, and a number of these technical fields I've been at the cutting edge. So I've been there when people claim all of these things, and this is just the same, same show, different day. And the deal is the theory and the research is not the same as on the ground experience when it comes to building the things and making them work. And research does not have a path to the thing that you're talking about. Building potentially has paths, but they come with insane levels of built-in constraints.
Okay. I'll also just say, so the audience knows my perspective and what I'm interested in. The reason I focused on a long division example is because I actually see it as very telling when I see LLM successfully do long addition without invoking a calculator tool. Because, like, even though they could bust out a calculator and use it, the fact that they're such broad tools, and one of the things that they can do is follow an algorithm, like the addition algorithm, or like compiling a piece of code. Like they could reason about code without sending the code over to an actual Python interpreter or whatever. They can actually say, hey, let me write this code, let me simulate running this code, but all within the LLM. The fact that LLMs can do that, even with like some loss, some error, much like a human, right? They can do it like somewhat imperfectly, much like a human, to me is actually a very important thing to know about LLMs, that they already have a handle on, true reasoning, like flexible reasoning about things that you could have a specialized device for, or you can use the general power of an LLM to do it. Like I can't, you really don't want to look away from this observation that LLMs actually are able to run algorithms to some degree, to a growing degree.
They are, but I hit the wall with them every freaking day. And I'm telling you, these things cannot go further than like it's they can't even make it out my driveway without me pushing it out there and paving the way for it. I I use just here's like a sake of volume, right? I used 8 billion tokens this last month. I used 1 billion tokens in 3 days. The volume of work that I'm doing on a daily basis with these things all revolves around their failure modes. All I do is run into their failure modes and then build systems to improve and manage for those failure modes. If I could get it to do as natively as the things that you're saying or believe that they're doing, that would be spectacular. They don't do that.
I mean, I agree that there's some boundary of what they can't do yet, and that's what you're going to find yourself doing up until the point that the boundary exceeds your own abilities. Of course, I mean, how could it be any other way?
Uh, where does where does the non-determinism become the weak point for you? So you said you don't see the power in it, and you're pointing out to A16Z, which kind of makes me like icky that I got associated with them. But you know,
I
so
mean,
be
you
it.
just gave an A16Z talking point, right? They really think. I mean, Mark Andreessen loves to say like sometimes the guy is like clearly wrong. You know, he was wrong when he said Web3, the web of crypto is the new web. Like, no, it isn't. It's just the old web. Crypto didn't really improve it. Similarly, he's saying that non-deterministic AI is the revolution. He's actually correct that AI is a revolution. Like, there's no doubt about that. But to make a big deal out of the non-determinism piece, that is definitely the least interesting piece that you could point to.
And see, that's the part where I take issue with, and maybe Mark Andreessen is getting it right for the wrong reasons, or maybe whatever. But that is exactly the capability that I rely on. So if I had a biggest fear, my fear is that someone would remove the non-determinism from the LLM because it will no longer be the thing that we think it is. It will no longer be
Let
capable.
me just be very clear, okay? What do you run the same prompt multiple times, the exact same prompt, and you really just need a different answer for the same prompt? Like, that's so critical to you?
Okay, I have never reused the same prompt twice. I don't save prompts. I don't premeditate prompts.
Okay, so you don't even know if it's non-deterministic because the definition of non-determinism is giving you multiple answers for the same prompt.
I I'm very certain of that. Like I think what I'm trying to point out is that the way that everyone using LLMs right now are using it wrong. You don't need to reuse prompts. You don't need to run these big templates of things. It isn't
Okay,
about that
so why do you like the non-determinism? Because you just said you don't reuse prompts.
because it allows more flexibility for edge cases internally. So, for example, I could create a regex parser, right? So every time sets of words come through, I'm going to use the regex libraries to do very specific ways and find patterns and pull them out. That would be a traditional and normal and the perceived best way to do that. I could also alternatively make a deterministic boundary with constraints on each end and then put the LLM into the box. And instead of saying, hey, LLM, here's your regex tool, I could say, LLM, pretend you're regex and parse this thing. And that non-deterministic capability is far more robust than if I build out a regex parser, because the regex parser is going to break every time something doesn't meet exactly. And the LLM, on the other hand, is going to go, well, I know it's supposed to parse this thing, but that thing's not quite right, but it is close to this. I think it's that. That
Got
is
it. So
spectacular.
you're not using non-determinism in the sense that people normally associate, like, oh, I need a probability distribution over what it's going to do, and then it's like there's randomness to it. You really don't care about that aspect. What you care about is the unstructuredness of it, right? Which is really that's actually a different concept than non-determinism.
Yes, but it's manifest as non-determinism, and if you take it away, it will break the same concept.
Okay, I don't think I agree that it's manifest as non-determinism because again, if I just set your temperature to 0, meaning the same tokens always follow the same series of tokens.
Won't work to say
Sure
you.
it will. I mean,
No, you cut
yeah,
off a
if I
ton of the
set the
train.
temperature to 0,
No,
you just map the same inputs to the same outputs and you're still fine.
when you change the temperature to 0, what you do is you completely change the light cone of where it's looking at its distribution. And so you're no longer
But you, for all you know, your temperature has been set to 0 and you admit you wouldn't have noticed because you never run the same prompt twice.
that's a weird claim to make. I would totally know, and I adjust the temperatures with
That's true.
purpose.
Even if you run a prompt once, you might actually notice that even just running a prompt once, you might notice that even if like you run 10 different prompts and you're like, why am I getting like such a standard average answer to all my 10 prompts? Why am I never getting kind of weirder, more off distribution answers? So you might even notice even without running the same prompts that your AI is like playing it safe with every token choice. So that's true.
Yeah, I mean, I can tell the second there's a change or an update, right? Like the patterns of behavior adjust. I currently there's a new twist in here where whatever wrinkle is going on in some of the context system within Cursor, it's now decided it's slightly more interested in accomplishing the near term test, and it's more likely to lose a little more sight on the actual goal that
Yeah.
we started at.
Okay, just to be precise though, okay, there is such a thing as setting the temperature to 2. So it's non-zero temperature,
Mhm.
but still choosing all the random seeds the same so that you still always map deterministically the same inputs to the same outputs. So I know this is probably, I think most of the viewers are like, who cares? But to me, it's just a profound point because I think there's this general point in computer science where randomness doesn't create value. Like, the only time when you really need randomness is, like, in cryptography, where you're trying to psych out your attacker or, like, you're trying to confuse your attacker because your attacker is going to try to seize on any predictability you
Yeah.
can give them. But in the case of, like, doing math or answering your question where there is no attacker, there is no need for intentional confusion and obfuscation, then you don't get value. You don't get smarter from introducing randomness or non-determinism to anything. And so when I hear Mark Andreessen come in and say, "Wow, non-deterministic AI with probability in it," I'm like, What are you talking about? That's not interesting."
I think it's simpler than that. The non-determinism really is, as you said, I'm just not necessarily going to get the exact same answer every single time. And I need that adjustment because I need it to not be so concrete because I intend to give it the context that it needs to give me similar answers. And I don't want that predetermined in there because I need the flexibility to put it into whatever box I want to.
All right, so that's that's AI non-determinism. So and we've zoomed in pretty far into this idea of like what can LLMs can and can't do, but I think very high level, you're basically saying you're so unimpressed with the limitations of AI capabilities, and I'm saying even if I accept that, let's say I even grant your claim, okay, yeah, LLMs are so limited, which I don't really agree with, but I'm happy to grant it as like, okay, maybe you're right, okay. If that's the case, don't you still think that we're going to keep making better and better AIs and we're going to keep going until we make an AI that's just better on every dimension than the human brain? Do you really like what are you seeing playing out in terms of like AI surpassing the human? To me, it's like obvious that they're going to surpass it.
I I don't I don't think it's obvious because I see a as we've established, I see a distinct difference between the underlying LLM's potential and then the software wrapped around it. I think the expressions that we will see of brilliance that come from these are going to come from the software that's wrapped around it. And I know that's some weird VC talking point, but whatever. Like rappers for the win.
So you're kind of saying like there's no such thing as like high general intelligence.
Yeah, because I come back to the part where the model itself is fundamentally limited by its potential. This interesting thing with this the takeoff that we've had so far, right? 70 years leading up to the point where we suddenly get an LLM that actually works. We're in a completely new regime and paradigm now. We're not in the end of this 70-year ramp up in AI and ML. We are now on the plateau on the other side in a new paradigm. And that new paradigm has an exponentially larger surface area than the one we just came out of. And that surface area is technical understanding that we're entirely missing. So I don't buy the general intelligence thing. I think AGI is the answer to a bad question. What I think is going to happen and where the brilliance shows up is the stuff that we're going to wrap it around, but it's so fundamentally limited.
Okay, I mean, let me just ask you hypotheticals, okay? Because I'm not, I can't always make sense out of people talking in abstract terminology. So let's try this hypothetical. It's just we upload human brains, right? So don't you think at some point in the next century there's going to be like scans of human brains in computers, and we can simulate them, the electrical signaling between the neurons, and don't you think within a century or so we'll get them running faster than a human brain runs?
I'm in line with Federico Fagin's thinking on this and follow if you've ever followed any of his work, but I do not think it's fundamentally possible to upload a human brain because I do not think a human is their brain. I think the essence of what we
Okay.
are is much more well, I just think it's provably much more it's a technically different set of concepts, right?
Okay, what are you? That's not just your brain.
Well, I'm a cell at the end of the day. At the root of a
Yeah, but the
cell.
cell is just scaffolding for the brain.
Yeah, but then you've got the gut brain, like you've got DNA that the research is showing is some form of fractal antenna. You've got a hell of a lot of technical details that are very, very important and unanswered about what it means for a human to be thinking. We are not just the brain; we are the whole set of information going through it. Like we would get closer to potential if you said, "I'm not going to upload your brain. I'm going to upload all of the information from your virome." your biome, and your brain. And then we got some system that connects all of those things, and we can handle all of that connectivity that's needed. That's a little more interesting.
I think a human has contingent parts. Like I don't think you really need. I mean, there's a very good analogy here. Like think about like an airplane versus a bird, right? So like at the end of the day, there's this property called like lift and power, right? Like power to weight ratio, forward propulsion, right? Steering. There's these certain building blocks that are actually important to building flying machines, and birds have like a healthy dose of, on all these dimensions. But when you build an airplane, if somebody's like, oh, come on, man, you got like the beak, right? You got like the legs of the bird. And it's like, well, not all of these bird things correspond to the building blocks of flight, right? So similarly with intelligence, it's like, okay, yeah, we have a gut brain, but like, does the AI really need a gut brain? Is that really the essence of intelligence? It can probably get by without it.
Yeah, and my time in sports tells me that is so wrong. That is to be more wrong than the concept of how an LLM works, right? I can walk in, if we know each other and you have had a bad meal the night before, I know before you've said anything.
Right, but isn't that just because I'll just be like, my stomach will be like hurting?
You are an expression of the entire system you are in. You are not just isolated to whatever is thinking between your ears.
I mean, I feel like you're taking a very holistic perspective, right? So it's like whatever my stomach is feeling during processing food, that's going to like affect how well I'm going to do math. Like math, don't you think there's like some modularity here where it's like, okay, mostly my performance in math will be determined by like my studying and like the intelligence that I came in with, right? The IQ level I came in with. Like the meal I had last night is just not going to be like a major factor.
God, your meat space is a certain amount of potential for sure, but it is not the whole thing that shows up, and so
Okay, well, so you really okay? So the gut brain. I was going to say. So you think? Imagine I was just able to pull out the entire nervous system, right, from the brain, the brainstem, complete with like all the nerves that go into every part of your body. Don't you think that like all of the nerves of a human, and including the neurons, constitute the human's intelligence, or do you have to go farther?
I mean, I generally think you've got to go farther, but then on top of that,
Okay.
like, well, I just that's not. It's provably not enough. Like,
I mean, what if you just wire up all the nerves into into electrical stimulation, right? Like, do you really need other physical effects besides electrically stimulating the nerve system?
well, I think if we go like, no one enjoys the reductionist argument for some reason. I think most of the time it's not reasonable to have the reductionist argument. But when we're trying to discuss about what can or can't be, I think it's important to acknowledge where the differences show up. And the fundamental differences between what an LLM is made of and what we're made of they're just entire worlds apart.
Right, but sir, I'm not even talking about LLMs though, right? I'm trying to make a hypothetical where because I'm trying to see how little you think of computation, right? So like I was trying to make an easy hypothetical of like, okay, just imagine an uploaded human, and you're not even willing to imagine an uploaded human.
Well, because I don't think it's a good, like, I think it's a bad line of thought because it's not plausible. Again, these are equivalent to the car flying away. We will never see an uploaded
Everything's
brain.
equivalent to the car.
Well, we're never going to see an uploaded brain. Like, if you want a prediction, I suppose that's untestable. We will never see an uploaded brain.
Are we ever going to see a module of 100 neurons that's artificial? Like the same way that they'll have like artificial organs. You don't think you can have like a structure of 100 neurons that gets swapped out for an artificial one?
Oh, I'm sure we could do some weird shit. Yeah,
So, but if you can keep swapping out artificial neurons into a real human brain, so isn't that just like one step at a slippery slope toward just simulating a human brain?
I sure, but I mean, there's a what? How many trillions of neurons delta
Yeah.
between those things? So like, I'm not opposed to there being a path to show up. Where I'm just going is I can't upload my brain into a computer until the computer is made of something that is not computer. It needs to be made.
What does it have to be made out of?
Well, look. Eliezer, in chapter 9 of Ascension or something like that, he was talking about like the advancement of biocomputers and stuff like that.
Chapter 9 of Ascension?
Yeah, of his new book. It was chapter 9's Ascension or something like that.
Oh, there's a chapter 9 in If Anyone Builds It, Everyone Dies.
Yeah.
I got this here.
Oh,
there we go.
perfect. There we go. Yeah.
Chapter called Ascension, you think? Let me see.
Yeah, and he's talking about nanobots and stuff in there. And
Yeah, chapter 9 Ascension. Yeah, it's the last chapter in part 2. And it's part of his extinction scenario. So I think he's using it kind of tongue in cheek or ironically, where it's like kind of the AI ascends, but it doesn't really take humanity with it.
Yeah, to get to some of these things, like he used the term growth, right? We grow these computers. We will not grow anything unless it comes from a cell. Doesn't matter how you want to call it, arrange it, organize it. So we got to have some control over the cell to be able to grow things. Like that's how things grow. We have no examples of anything else. You could say a crystal grows, but it just propagates, right? I don't know. I don't know what level you want to play at those things, but
I mean, doesn't a computer virus grow?
it copies. But I don't know if growth is a different than expansion, right? Like I start with a single cell and I become what's standing in front of you. That's growth. If you copy me, we expand.
What about a computer virus that just coordinates bigger and bigger server farms?
Um, most computer viruses are pretty unsophisticated. They rely on mistakes and faults in other
Yeah, the
systems.
ones that exist. I'm just pushing back on your claim that like you need biological cells to grow. I mean, the biological cell is a beautiful thing, but I don't think it's got a monopoly on what can grow.
I think it seems to have an entire monopoly on what grows.
For me, it's very easy to imagine a virus that, even existing botnets, right? I mean, yeah, botnets have human intervention, but botnets do a lot of autonomous growing, in my opinion.
I would say they expand. This might just be a semantic
Okay,
argument,
they
but
just
like,
expand. All right.
well, you're just expanding in scope and scale, but like, there's no growth going
Just
on.
expanding, just cloning, not growing.
Well, it's not growing. It's not It's
Okay.
not becoming a new shape. It's not like It's not extending its capabilities. It's not applying some learning. It's not giving birth to new things. Like it's copying and it's expanding and it does what it does that it was programmed at.
All right. So you think human intelligence is made out of something besides electrical signaling maps between neurons, correct?
I think it's pretty clear that it's at least powered by a proton hopping on the back of an electron at every 10 angstroms, and that the inside and the bottom of my LLM is just a gate. And I know that reduction again is kind of not
Yeah,
is
yeah. So let me clarify your position. Okay. So you think that if we were to simulate on like the atomic level a human brain inside of a computer, and the computer didn't have cells, and the computer didn't even necessarily have carbon atoms, or it didn't have like DNA or whatever, right? So the computer was like a very different substrate. But if it was running a atom level physical simulation, then you do feel confident that it would very slowly and painstakingly simulate human intelligence, correct?
I think if you can get down to an atomic level and in theory you were playing like programming all the way up, then yeah, then maybe the answers that I would have would be entirely different.
Okay, it sounds like you just think that maybe the essence of intelligence, like it sounds like you don't feel like that it's merely at the electrical signaling level of neurons, right? You feel
Correct.
like there's some lower layer of the stack that we really need to model. Like you really need to model what hormones are there above and beyond the way that they electrically influence neuron firing.
Yes, we can go with the holistic. I have a much more holistic approach. I don't feel like that, discredits it, but I know some people don't like the holistic nature.
Okay, and that makes you think it's going to take longer to simulate human brains. All right, well, fair enough. Fine. So what if we just simulate physically, or we say we just get enough detail in the simulation? So don't you think that's going to happen in a century or 2 centuries or a millennium? Like, don't you think that's eventually coming?
I I think we're potentially capable of quite a bit more than we've accomplished so far. So perhaps we're growing things from cells in a million years from now or 1,000 years.
So there's gonna come a day, right, when humanity is going to be about to create, all right, be on the threshold of creating. And like I said, I think this threshold is like a few years away, right? I think we're like very close to it. But it sounds like the only difference between me and you is I think we're like a few years away, and you think we're like, I don't know, a century away. But we both think that there's this threshold coming.
Okay. I'll go. I think I think we're 1,000 years away from growing
Okay.
computers, but
Don't you think that either of us could plausibly be right? Because remember the famous anecdote, right? The Wright brothers were saying, I think Orville Wright was saying like man cannot fly for like 1,000 years or something, and then like 2 years later, like he made the first heavier than air flight himself successfully.
yeah, I mean, what's the question in that one though? Like
So don't you think that like, so even though you're claiming right now, like, yeah, it's gonna take 1,000 years, don't you think that it might actually just take a few years?
I mostly don't.
Okay, mostly don't, right? Don't you think there's like a few percent chance that it might just take a few years? I'll give you this. I'll give you a few percent chance it might take 1,000 years.
I think as we anything less than 100 years feels highly suspect. I wouldn't bet on anything in 10 years, and
Okay, highly suspect, but can you give me 5%?
I'm going to annoyingly give you a frame of reference I have for this again. In my experience, being on cutting edge fields, anything predicted within 1 to 2 years shows up within the 1 to 2 years. Anything that's predicted 2 to 5 years takes at least 10 years. And anything where someone says 5 years, 20 years down the road, you still won't see any changes. I don't
Okay, I think it's coming in 1 to 2 years. What do you say to that?
I I think in this case, I think it sounds a lot more like you're 2, and I think a lot more like it's 10 plus years minimum.
All right.
And I think that's simply because the surface area of technological learning that we have to do is so big, and that we can't get over some of those steps without those learnings. And we might be on an exponential learning curve, but we still don't have if your space is exponentially larger, it doesn't matter. You need all of that time.
Okay. So let's just hit this point last then, okay? So let's say we get to that time, whether it's in 1 year or 1,000 years, we get to that time when we have a smarter than human intelligence, faster than human, take the smartest human who ever lived, a million clones of that human, all communicating to each other, all saving all their information, right? Anytime one of them learns something, you can easily teach it to the rest, in a millisecond. So you've got the system that's like really powerful, and the human brain is kind of slow compared to it. So don't you think that there's a pretty large risk of losing control of a system like that?
I still simply no, because even just like the basic current limitations, which relevant to me, like if there was 100,000 users out there like me, we'd be underestimating potential power capacity to even provide that back by 200%. If any of the systems that the people like me are building start getting adopted by other users in with any sort of mass, let's say there's a 100 million user product.
So just sorry, the direction you're going with this is you're just saying that like, yeah, in 1,000 years, this super smart system might exist, but I'm confident that it'll be like so power hungry. Is that basically what you're saying?
Everything is so power hungry, we can't even get over the next step. The next step in this chain, we have no potential to reach right now. None.
Okay, even 1,000 years from now, right? It's going to be like we're not going to figure out how to not make it power hungry 1,000 years from now.
I mean, I guess I just won't. I have no concerns about that future. And it's all entirely moderated by the fact that we don't even have the potential to take the next step right now, let alone the 100 steps required to get to that.
Right. I mean, so remember, I am factoring the argument, right? So I'm just talking about the part of the argument where, like, when we get the superhuman AI, which it sounds like you and I are both on the page that we're eventually going to get it. And I'm just asking you what you think we have when you get it. And I know you're saying, well, I think that time is far away, so I don't want to talk about it. But can't we just talk about it hypothetically? Isn't that because here's the thing: one day something might change your mind about the piece of the argument. Something might change your timeline. And when that day comes, isn't it useful that we will have already discussed what happens hypothetically if if we're faced with smarter than human AI? That's why I want to discuss smarter than human AI.
I I I mean, I guess. I just don't know how, like, my head doesn't live in that space ever. Like, I don't in the space of like impractical and impossible, I don't go to. I try and find the edge of what's practical and plausible.
Yeah, sure. Okay, so you're basically saying, look, I've already gotten off the doom train, right? I already think that I'm just so unmotivated to think about a hypothetical future where something exists that's smarter than the human brain. So, like, whatever happens then happens. We'll discuss it in 1,000 years. That's basically your viewpoint.
It's not that I'm unmotivated. I'm entirely motivated to find that. Like, I want to find a disaster because I don't want to walk into a disaster. I don't want to be the one that built. I want to build the thing that everyone, if someone builds it, everyone dies, right? I don't want to
You
build.
do want to build that? You don't want to build that. Okay.
I 100% want to build the thing Eliezer's thinks he's scared of, but I don't want to build the thing that kills everyone, right? And I don't think that's really that difficult because I find it nearly impossible to figure out how to even make that happen.
Right. Okay. So again, I think I correctly summarized you as just saying like you are so confident that we're not going to get smarter than human AI anytime soon, and because of that, you just think that all of the scenarios conditioned, all of the dangers of smarter than human AI are just not even worth talking about because it's so far in the future. Correct?
I guess so. Yeah.
Yeah, I mean, I think that's, we can wrap on that crux. I mean, I just think it's like I understand why you might have some reasons making you think, okay, yeah, it's less than 50% chance that in this generation we're going to have smarter than human AI. And I think it's totally reasonable to think you have a reason why it's less than 50%. But when you're so confident you won't even give it like 5%, to me, that's weird because it's like we have such a track record. Humanity has such a track record of like making breakthrough after breakthrough, specifically in the domain of AI, but also in the domain of like computing and electronics and technology in general. I mean, I can tell you personally, I was always a technophile, right? I was always somebody who kept an eye on technology and was really interested in technology. The level of smartphone that I had today, or even in my early 20s, would have blown away my expectations as a teenager, right? It's like 10 years pass and like crazy stuff happens, man. Like I just feel like a basic extrapolation should make you worry that smarter than human AI is coming.
But I've been doing these extrapolations for longer than you guys have been thinking about it. I started building these scaled up systems more than a decade ago. I've done all of the math on the processors and what
I mean, did you predict we were about to pass the Turing test? Didn't that surprise you?
I you can go back and look at my track record of the things that I said in Silicon Valley and who I positioned them to and what our systems did. I had 1 million devices that were distributed globally around the world, connected, shipping data all over the place, building systems that people said were never going to be useful, couldn't be built, or wouldn't do the things that they did. I think in my experience in building
So you're
stuff,
saying progress can happen fast, right? That supports my argument.
I think progress happens fast within a relative potential. I think what I'm saying is I've experienced quite a few people in my life who are risk averse, and I know what that thinking looks like. And I hear the arguments and I hear the stories. But I think if you're on the ground building the stuff and at the cutting edge, I don't mean going to piece together some APIs with Legos and stuff like that. I mean trying to build these systems that do these things. I want the system for myself that is fully autonomous. I want to run my box. I want to have it do my work. I want that. I
Right.
have the motivation. I have the potential. I have all that. And yet it's extremely difficult. And the scale and the scope going on the decades of trajectory and planning and working towards these things are still very far off from a lot of them.
Okay, I just, I'm not really liking how I said if you're on the ground working the stuff, because I get that you're talking about yourself. I get that your opinion is that we're not close to superintelligence. But if you actually look at the set of people who are, to quote you, on the ground working on this stuff, many such people who are on the ground working on this stuff, not even AI doomers, AI optimists, people working at OpenAI, DeepMind, Anthropic, Dario Amodei himself, many of these people are saying, hey, we're getting close to superintelligence. So you want to start your sentence with if you're on the ground working on this stuff. I think the end of that sentence goes, there's a 50% chance you're warning everybody that superintelligence is near.
Nah, I think it's super easy to look at why those guys are conflicted in a bunch of different directions. And then I also think it's super easy to see that historically the people that are the researchers that build the stuff, and I don't just mean AI, are not the
Yeah.
ones that actually understand how to use the things correctly or what their real potential is.
Okay. So in your mind, the class of people who we should trust are people who are on the ground building the stuff, but haven't joined a company that's on the ground building the stuff, which is yourself. You're the best authority.
I I'm certainly in the top 1% of how these things work. I mean, I've got 15,000 hours of working with LLMs directly, unmitigated by any other companies or anyone else's intents or directions. So, and I don't
Okay.
think I'm the only one. I think there's a bunch of us. I actually think I think the other people like me are being ignored, and hilariously so, while people who've not built any of these things are pondering ideas that I understand. But I had a CTO once. He used to call it plastic bag ghosts. And what he meant was if you put a kitten in a room in a plastic bag, the kitten gets into the plastic bag and it starts freaking out because the bag is like alive and like the world's ending and like chaos ensues and stuff goes in all direction. There's a lot of plastic bag ghosts out there.
Sure, sure, sure.
And when you don't have hands, here's the part where the building to me becomes relevant because it's hands on around the third rail. The engineer laying the rail, the electric rail that the train's running on, they're the ones that understand the real risks. Not the person in the boardroom talking about it, not the person in the research lab thinking about the next one. The person on the ground knows what works, knows what doesn't work, and has to touch or touch near the third rail. So they're the ones that are getting electrocuted or not. And I just think that the hardest thing in tech is that you've got people playing with tools that are mostly invisible, that can do powerful things. And most of these people don't have a good grounding in what risk really is and how to work with it. And I think that's expressed in the words that they use most of the time.
Okay, well, we can wrap on that. Let me recap some of the major points that we hit and then tell me if I missed anything. Sound good?
Yeah, sure.
All right. So first we talked about policy and this general idea of should you divide the world into these independent, decentralized, independently governing bodies? And if so, would you have this big risk of like nuclear proliferation, and would mutually assured destruction still help? Would that really hold as an equilibrium then, or no? And I said no, and you seemed really optimistic that it would hold and things would work out. And then we pivoted because we said, well, regardless, that's not even something we have to discuss because AI is so far from being an existential threat in your view. So then we talked about, do we know about the limitations of LLMs? And I seem more bullish on how far LLM based technology can go compared to you. But ultimately, that didn't matter that much because I just claim that AI systems will get better and better, whether they're mostly LLM based or not mostly LLM based. I just claim that they're going to keep improving on the benchmarks. They're still going to get smarter than humans one way or the other because I've seen AI break through so many benchmarks using so many approaches. Like the AI industry has solved many seemingly impossible obstacles. That's the perspective I have. So we covered that, and you disagreed, of course. And then we talked about, do you think that AI is close to surpassing human intelligence? And you gave a very emphatic no. You threw out 1,000 years as the amount of time you think it'll take. I think it's more like 5 years, maybe 10, ballpark. I like to say like 1 to 30. So I don't try to be like super precise about it, but 1 to 30, I get really shocked if it's more than 20 or 30. So we talked about timelines, and then we talked about, what happens when the intelligence comes. And you were saying like, well, maybe something bad will happen, but it doesn't matter because I'm so confident that it's not going to happen. And then we talked about who we should trust, like who's really on the ground having a good opinion about this stuff. And you think that people like you who have the 15,000 hours of experience are unanimous as long as they don't have corrupt incentives. They'll all tell you that there's nothing to worry about, right? I feel like those are the major points we hit.
I I would push back on most of those as being characterizations, like caricatures of this stuff, but
Okay.
like I don't know, it's fine. It's a fine characterization at the same time. So it puts me on the right side.
Okay, I'll give you the last word. Yeah, so you can make a closing statement and leave viewers with I don't know, a summary impression of your view.
I think what AI is going to bring in will be amazing. I think a bunch of it is going to suck before it actually works awesome. I think most of the underlying models themselves don't have that much more room, at least for now. They require new innovations because you've already gotten 60-70% of the juice out of that. That doesn't at all touch the software that's being packaged on top of it. I think this is a lot like, discovering electromagnetism. It starts with a stick that's spinning circles in the sand, and then you realize, we can build motors. I think we've got a distance before we get there. I think wherever there is that we get, we're all going to be fantastically smarter than we were before, and whatever version of brilliance that is, it's certainly more than we've got now.
Nice, man. All right. Well, we obviously disagree. I think our opinions are kind of light years away. Like, there's a lot of irreconcilable differences here. Maybe one of us will update. Maybe something will make me think that we're getting into an AI winter. Maybe something will make you think that the timelines are actually fast. Maybe it'll pass milestones that you're not expecting. And then we can potentially do a round two. But I just want to thank you for, coming in, hashing it out. You were totally game to answer all the questions. And I appreciate that. I think this show is facilitating good discourse.
Yeah.
And thank you for being a part of it. Devin Elliot.
All right. Thanks for having me. Really appreciate this.